So here's the winter project to be run in parallel, since the Progress 4E is going to need brazing for a lot of it, so that'll be pushed off to the spring, maybe some painting for other parts in between. But this is a Mitutoyo digital readout from probably the late 80s, early 90s, and it's no bueno. Oh, that worked this time. Neat. So it only took 4 clear, whatever. I'm gonna try to fix this on the inside, see what's going on. Nothing's working up there. So buttons don't work, this doesn't work. Okay, so here's the DRO screen, which is obviously having some processing problems. All these connectors on the inside look fine. There was some evidence, I mean, you can see a little bit of evidence of corrosion here, so I suspect we have something on the inside. Maybe some coolant got splashed up and somehow got on the interior of this and which is causing the problem, but I'm not sure. So, I'm gonna go ahead and get into it and then start doing a little bit of electronic stuff, I guess, over the winter here while I clean up and sort of run 2 restoration projects in parallel. So these also have a ton of the world's most annoying coolant concrete metal shavings, spikes of death plastered to them. Condition of the glass scales on the inside, from what I can see, is actually still okay. So I guess we'll see. So the shell's off. I was actually starting to unscrew this. A little bit of problems through here. So everything's out, so I'll be able to actually get this one out now. So it's a shell that sort of attaches. And I get to see if there's any big old problems. Okay, so just trying to help my future self out here. Taking these off in order. The back of the board looks fine. So I wonder what the problem is. So nothing totally evident here. Worst case would be those controllers. Okay, so with all these little tiny screws out, we should have access. I bet you these are screws too in a way. Yep, they are. To this board. There's a lot more corrosion on this side, but that doesn't sort of ring with what I would expect for the source of the problem. Maybe it's here. Okay, I didn't really expect that. I thought we were going to see another board. We have a part number sticker here at the back. Was that a whole bunch of 3, a whole bunch of 0s, 79? Anyway, I guess we'll be testing this. Looks like it's been sandwiched together. It'll be an annoyance. But as long as we provide power to this, we should be able to test the output to see if there's actually anything there. Okay, so took this plug off here as I was starting to notice something, but that looks a little bit warm. So maybe our capacitance isn't where it's supposed to be, and that's what failed. I don't know. It's the thing that looks the worst out of all of it. So this is the underside. That looks repaired almost. This is a large resistor, a 9 kilo ohm, excuse me, yeah, resistor. So, I wonder if that's what did it. Okay, there we go. 4. That ain't right. Womp womp. Also, just as a side note, an errata there, it wasn't 9 kilo ohms, it was 3.9, so the reading of 4 is fine. So what is going on? You can see through the frame rate of the phone that the middle bar is not stable relative to the other LCD. It's sort of cycling in hertz. Part of me starting to lean towards a microcontroller, which sucks. Okay, so another non-invasive way here. What we got? So those chips are warm, but nothing else on the body of that seems to be like a problem. And then when we go over here, you know, we expect that cement resistor, I'm gonna try to get a better shot, to be warm. It is, and a couple other resistors warm, but the transformer's not even warm, so. Obviously the resistor there gets pretty hot. So maybe it is just bad, I don't know. Okay, we got one line in. Contact. Okay, so the next step in this process is to isolate the major components. We know the output of this, thanks to the excellent labeling, is supposed to be 5 volts and up to 5 amps. So we take out the DC bus, flick it on, after I attach it with some random copper wire. Oh yeah, what up, safety? Okay, here we go. And contact. So I have it preset at 5 volts. We're only drawing a small amount. And we've got that switching problem again. But now we can go clear. Watch. Clear. Then we can select that it's going to be Z, Y, X. So we select X, flash. We can tell it to put in its coordinates, so 8555. And it'll error out once you reach too much memory, so clear. Y, go Y, and we'll do 7, 7, 7, 7, 7, 7, 7, kablam, errors out, clear. Here's Z, we'll do some 9s, and it errors out, redo. And we'll do X again, just for good measure, a bunch of 2s, there. So that works, and then we can go to the LEDs. Those functions change. These functions change. Kids fight. But anyway, the problem's not here. The problem's right there. The low voltage is coming out of there is not enough. It has to be 5. Less than 5 is low. Okay, time to deal with the kids. All right, so this is going to be the new driver. Gonna plunker stilt skin that pretty much right there, and we should be good to go. Just got to find a way to drill and tap it. Put some bolt in, and stretch the wires, make some new ones, attach it to the motherboard, and then this part of it is done. Okay, with that mounted, I'm gonna chop these off, put them in their place, get the ground set up, and just go forward. So not too much really to film here other than just making wires, so yeah. Okay, so with the new supply on, we're hitting 5.2. So I'm going to go in there and try to reduce that to straight 5, because I'm not sure that it really, well, we saw what the behavior was just below 5 volts. So yeah, I'm going to tune this down, get one of my proper screwdrivers for that, since we're going to power through it, even though it's insulated. So I'll drop it down a little bit and then we'll see what happens. So a quick little change of plans here. You can't build it up like this as easily because you have to be able to use the back screws to tighten everything down. So you got to start with a face. So face down. Yeah, you know the rest of that expression. All right, here we go. Okay, so now with the poles there, I'm going to fit the outer shell around it and then proceed to, I guess, sort of do 2 things at once, really. Since it's going to be kind of tricky, this part, but this is the only way I think I can get it done. Okay, everything's back together minus that one fastener. Everybody's always lost that one fastener. It's, you know how it is anyway, so here we go. Okay, that's actually what it's supposed to do. I found a manual for it. So we'll clear it. Good. Stable. X. 8. 8. Oh, that's good. It should clear now. Yep. Can't have more than that. And we'll go Y. 8. 0. 0. 8. 1, 3, 5. Oh, okay, we did that. Okay. Here. Increment absolute value, inches, millimeters. There we go. And we'll try it with this. And yep, this is about as good as I can probably get it.